All right, so now, I'm sorry, if we go back to this front page and we talk about vertical stretches and shrinks, that is when you have a number in front of x squared. Okay, if there's parentheses, it's out in front of it. Okay, you might also have that negative there, but that was just reflection. This is the number we are concerned about. If it is greater than 1, it is a vertical stretch. If it is between 0 and 1, it is a vertical shrink. Now, notice we don't say less than 0 because if it's negative, that just means reflection. Okay, so now go over to number 5 in the practice, or in the notes. And we're going to state the transformations that are occurring. And I always start from the left and kind of read the equation from left to right. So on the left, it has this 1/3 multiplying x squared. So that means I have a stretch or shrink. It is less than 1. It's between 0 and 1. So I know I have a vertical shrink. If you just write shrink of factor 1/3, if you just write this part, I still know what you meant. If you see on Big Ideas the word horizontal, we don't do that. So you know that's not right. It's got to say vertical, okay? And then we have this -6. Well, it's tacked onto the end. It is not grouped with x. Therefore, it's going to move us up or down, and it's negative, so it's actually going to move us down 6. Okay, so we had those points I told you to eventually memorize here. If I square 1, I get 1, 2, 4, 3 squared is 9. And now I have something in front of x that is multiplying x. So I'm going to take that and I'm going to multiply all the y values by 1/3. Now, I find it easiest to graph decimals than it is to graph fractions, so I don't write them as fractions. I go ahead and say, okay, 1 times 1/3 is 1/3, which is 0.3333 repeating, whatever. But 0.3 is going to be how I graph it. 4 times 1/3 is 4/3, but as a decimal, it's 1.3 repeating, or 1.3. And then 9 times 1/3 is 3. And I don't know why I made that look like a decimal there. That was really weird. I'm sorry. I don't want to confuse you here. So that was just 1.3. Okay, so if I graph these, first I have to graph that -6 there. I have to graph that I said that vertex is going down 6. So that's the only translation. To get the vertex, you always do those translations first. Did it go up or down? Did it go left or right? Put that point. That is where the vertex is. That's our 0, 0 in our table of points. Okay? So from there, then I'm going to go right 1. And since the y is positive 0.3, I'm going to go right 1 up 0.3. I also have to go left 1 up 0.3. I go right 2 up 1/3, or up 0.3 from that vertex. From the vertex, I go right 3 up 3. And left 3 up 3. Now, because we shrunk it, you see how it's getting wider than they were before we would do any shrinks or stretches? We can actually fit more points onto this. So if I extend my chart here, I know if x is 4, 4 squared is 16. And then I can take 16 and I can multiply by 1/3. And I actually get 5.3. So that's another point I can put on there. From my vertex, I go right 4. 1, 2, 3, 4. I go up 5.3 and put another point. And you can keep going. You could put 5 in for x. X squared is 25. Times it by 1/3 and get a point. But this is good enough. I know that my graph is right here. Got a little wider than that parent function. Okay? Then it wants that vertex. Okay? Well, the vertex, we use what's in with x squared as the x value. In this case, nothing is grouped with x, so that means my x value of my vertex is 0. The y value is whatever is added or subtracted to the equation, and in this case it was -6 or -6, which makes it a -6. Okay, and if we look at our graph, what we plotted, the original vertex is right here, and we went down 6, so my vertex is at 0, -6. All right, domain still has those arrows on the end. All real numbers, -infinity to infinity in interval notation, and then range, it goes all the way down to -6 and goes up forever, so y is greater than or equal to -6. All right, so now let's go to number 6. We need to write what's happening, and like I said, I like to read it from left to right. So it has this 3 out front being multiplied to x squared, or whatever's in that parentheses being squared. So I know that is a vertical stretch because it is greater than 1 of a factor of 3. And then inside with x, so I know I'm moving left or right because that's the way the x-axis goes. This says -2, which is left, but we do the opposite thing. We're actually going to go right. So I'm going to go right 2. And this +1 on the end here moves us up or down, and it's positive, so I'm going to go up 1. So I can go ahead and place my vertex. I said I go right 2, up 1. So from 0, 0, I go right 2, up 1. There's my vertex. So I can go ahead and actually write that vertex. It was at 2, 1. Okay. Then we need to graph the rest of it. So I'm going to get those points, 0, 0, 1, 1, 2, 4, 3, 9. Whatever's in front, multiplying the x squared or the parentheses being squared, I'm going to multiply the y values by that number. So times 3. Actually, let's do that in a different color, sorry. So 0 times 3 is still 0. 1 times 3 is 3. 4 times 3 is 12. 9 times 3 is 27. Okay. Obviously, that's not going to fit on my graph, but if it did, you could plot it. So my vertex became this point right here, became that 2, 1. So that's my 0, 0 in my chart of points. And then I'm going to go from there. I go right 1, up 3. I also have to go left 1, up 3. I go right 2, up 12, and that takes me right off my graph. So I can't even plot that one. So I know it's a really skinny graph. Remember, stretches get skinnier and taller, shrinks get flatter, closer to the y-axis, okay? All right, so my domain, still arrows on the end going left and right, so it's all real numbers, -infinity to infinity. The range, it has a bottom to it, and that bottom was when y is 1, but it goes up forever, so it goes to infinity. So y is greater than or equal to 1. All right, now in your practice, sorry, let me move it again. You can do numbers 17, which I think I had you do already, but you could do it if you didn't. 20, 24, 26, 27, and 28, and then move on to the very last video.